Welcome to the Tambopata Research Center. My name is Dr. Don Brightsmith, and I would like to tell you a little bit about the research we've been doing here for the last 10 years. Tambopata Research Center is located in the lowland rainforests of the Tambopata National Reserve, just on the edge of Bawaha-Soneni National Park. The rainforests of eastern Peru which surround the lodge are famous for their incredible diversity of birds, butterflies, plants, and other forms of life. The lodge is located in a small clearing near a large clay lick where hundreds of parrots and macaws gather daily to eat soil from a cliff along the river's edge. Here, mealy parrots and blue and yellow macaws join red-bellied and fronted macaws as they push their way in to get a chunk of this special clay. During our research, we have recorded 16 species of parrots coming to eat soil at this clay lick. We have also recorded tropical forest pigeons, along with the turkey-like iguanas and curassows. We have estimated that as many as 1,700 birds may use this clay lick on a good day, and nearly all of those are parrots. One important part of our research has been to determine why birds eat soil. There are two main theories. The first is that they eat it as a source of sodium. The second theory is that the clay in the soil helps protect the birds from the natural toxins in their diets. We have been studying bird behavior at the clay lick since 2000, and during this time we have found strong seasonal changes in the number of parrots that visit the clay lick. When we combine the data from all species, you can see that there's a marked increase in clay lick use from August to January. The wet season here in the Peruvian Amazon runs from late October through April, so the high season of lick use spans both the dry and wet season. If we focus on one species, like the blue-headed parrot, you can see that there's a strong peak in lick use from July to September. And this peak in lick use corresponds perfectly to the season when the birds are nesting. Now, if we look at the data for the blue and yellow macaw, we find that the peak of lick use is in a completely different part of the year, December through January. But once again, this is exactly the time when the birds are nesting. Now, this leaves us with the question of why does lick use peak during the breeding season? But to answer this, we need to take a closer look at the nests of the macaws and parrots in Tambopata. Each day during the macaw breeding season, members of my research team climb 30 meters, up to 100 feet, up to the nests of macaws which live in the forests around Tambopata Research Center. When they get to the top, they check the nests for eggs and chicks to determine the nesting success of the population. When the nests have chicks, we lower them to the ground where we can weigh them, measure them, and check their health. The chicks are altricial, which means they are naked and basically helpless when they hatch. About all they can do is raise their heads and beg for food. They're brooded by their parents almost continuously until they are at least 15 days old, when they can begin to thermoregulate for themselves. Recently, we have also been working with veterinarians from Texas A&M University to study the health status of the birds. By analyzing the body condition, blood, and feces, we can determine if chicks are sick or dehydrated. We can also use samples from healthy wild chicks to give us a better idea of what a normal healthy chick is like. This information can then help veterinarians improve the health of parrots in captivity worldwide. We have been working with chicks since the beginning of the project in 1999. We're using the data from the chicks to describe the growth patterns of the species and compare them to the growth of other species of birds to better understand how bird growth changes among different families. Here we can see the weight gain curve for a normal healthy chick. It grows slowly for the first 10 days, then grows rapidly until it achieves a maximum weight at about 50 days of age. At this point, the bird is just a little ball of fat which weighs even more than its parents. Then, through exercise and diet, it loses weight and gets into shape and ready for fledging. Now I would like to show you a photo series of the development of a normal scarlet macaw chick. This bird is just hatched. Its down is still wet, and it still has a bit of egg membrane on its back. At 2 days old, the down feathers are fluffy and dry. Here on this 4-day-old chick, you can see the egg tooth. The birds use this barb on the beak along with their large neck muscles to break their way out of the egg. By 14 days old, the ear canal is usually open. Here a 16-day-old chick holds his head high during the veterinary examination. Around day 19, the eyes are beginning to open. By day 24, you can see the first primary feathers starting to form. Here you can see the growth curve for the part of the foot known as the tarsus. Over the first 25 days, the foot grows very quickly, allowing the bird to stand up tall and beg for food. Then at around day 30, the foot reaches full adult size and pretty much stops growing. By 34 days of age, the wing's secondary feathers are forming, and the bird is starting to show hopes of becoming a rainbow-colored beauty like its parents. At 49 days, the crown feathers have grown in, but the rest of the body is still covered in down. Here you can see the normal growth of the macaw wing. It grows slowly at first, as the body concentrates its energy on growing the foot. Then, from about age 30 days to 80 days, the wing grows quickly as the bird prepares for fledging. However, even when the bird fledges, it usually has wings shorter than those of the adults. By age 83, the bird is fully feathered and just about ready to fly. Compared to the adults, its beak is smaller and the wings and tail are shorter. As a result, it neither flies nor feeds particularly well, and when it fledges, it's almost completely dependent on the parents for the first 4 weeks. The chick then stays with its parents for up to a total of about 7 months, while it finishes growing and learns to forage on its own. In over 10 years of nest monitoring, we have found that parents usually lay 2 to 4 eggs and 1 to 4 chicks hatch. Sometimes second chicks die when they are young, but when second chicks do fledge, our data show that they are big and healthy and probably have a good chance of survival. However, the third and fourth chicks that hatch usually die. In order to determine why some chicks are dying in the nests, we have put small video cameras in some of the macaw nests to spy on their personal lives. We had two ideas as to why the chicks were dying. The first was that the older chicks were pushing the younger birds out of the way and not letting them get food. Our second hypothesis was that the parents themselves were making the decision of which birds to feed and which ones to ignore. By watching hundreds of hours of videos, we have found that the parents make some very clear choices about their parental care. It seems that the mother chooses very clearly which chicks she wants to have survive and which ones she doesn't. For the chicks that she chooses, she preens them, broods them, and feeds them almost constantly. However, the chicks that she has decided she does not want, she often leaves sitting alone and cold in the far corner of the nest, while she preens and broods the chosen siblings. The unwanted chicks will beg for food, but the mother will ignore them as she tries to force the older siblings to eat more and more. As a result, the unwanted third and fourth chicks beg incessantly as they slowly starve to death. It's hard to imagine that this behavior from these beautiful birds, but nature has its own set of rules. Over the years, we have found nests of other species as well. When we map out the months in which the most common parrot species breed, we come up with this graph which shows a low in breeding during May and a high in November. This corresponds to a low at the end of the wet season and a high at the end of the dry season. Since we have lots of data on scarlet macaw nesting, we can take a closer look at the relationship between nesting and clay-lick use for this species. As with the other species, clay-lick use peaks during the breeding season for scarlet macaws. However, we have found that clay-lick use jumps greatly just after the chicks begin to hatch. The reason for this became clear when we began to collect crop samples from the chicks. Turns out that the macaws are feeding clay-lick soil to their chicks. The natural macaw foods in the forest around TRC are really short on sodium. The average food has less than half as much sodium as lettuce. As a result, the soil likely provides an important source of sodium for the young, growing chicks. As they grow, the need for sodium is apparently very high, and the parents use the clay-lick a great deal. But as the chicks near maturity, they are fed less sodium, and the parents may get a break from visiting the lick. To better understand what could be driving this nesting pattern, we have had to search the forest to determine what the birds are eating. This often required walking remote trails and listening for the sounds of seeds and fruits being dropped by foraging parrots. But with a little luck and persistence, we built a database of what the birds eat. The next step was to determine how the amount of food available in the forest changed throughout the year. To do this, we checked hundreds of trees per month to determine which had flowers and fruits that the parrots could eat. Since tropical forests do not have a long, cold winter like the northern areas, people have traditionally thought that rainforests have little seasonal change in the abundance of fruits and flowers. However, what we found was quite different. In fact, the amount of food in the forest does change annually. We found a low in food availability from February to May, and a high from June through January, right at the time when the parrot nesting is at its highest. So this suggests that parrots breed during the time of highest food abundance. Our data show that there's a strong low season when both claylick and food abundance are very low. This begs the question, what happens to the birds at this time of year? Do they leave the area, or do they remain and just not visit the claylick? To answer this question, we have implemented a series of about 20 census points scattered throughout the forest where we count parrots about 5 times each month. Finding parrots in the tropical rainforest is not easy, but by learning their calls, we can often find them even when they are tucked away high in the canopy. Our data show that there are significant changes in the number of macaws and parrots in the forests around TRC, suggesting that some of these birds do in fact leave the area at certain times of year. To determine where these birds go, we have begun a study of macaw movements using satellite telemetry.
Can you just hold them on the side of the head like that? Like that with his beak closed?
With satellite telemetry, we attach collars to macaws and release them. Then, once every 5 days or so, the collar sends a signal to satellites orbiting the Earth. This signal is then processed by the Argos company and sent to me via email. Our preliminary results suggest that the birds may travel nearly 100 kilometers, that's about 60 miles, in times of low food abundance. Unfortunately, these travels may take the birds outside the protected areas and near roads where they can be exposed to hunters, loggers, and even nest poachers. Recently, the Peruvian government, in partnership with Brazil, has agreed to build a paved highway which connects western Brazil to the coast of Peru. Unfortunately, this highway will pass within 30 kilometers, or about 20 miles, of TRC, and the risks to our beloved forest and the macaws that live here are great. However, we are working with the Peruvian government and local conservation organizations to help ensure that the macaws and tropical forest wildlife can continue to survive, even as progress and development reach this remote corner of the Earth.